Dear students, welcome to mathematics online classes. Inverse trigonometric functions. We have covered up to problem number 8 in the previous class. That is miscellaneous exercise we are solving on the inverse trigonometric functions. Now, ninth question we have here. Prove that tan inverse of root x is equal to 1 by 2 times cos inverse of 1 minus x by 1 plus x. Here, to prove this, let me take RHS. RHS is equal to 1 by 2 times cos inverse of 1 minus x by 1 plus x. This is RHS we have. Now, 1 minus x by 1 plus x, we can convert this form into 1 minus tan square theta by 1 plus tan square theta. We have the formula for cos 2 theta here. So, I will try to use the formula cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. I am using this one. See, to have this formula, I will substitute x is equal to tan square theta here. Okay, what you do? You substitute x is equal to tan square theta. I have to separate for theta finally, because if the answer is in the theta, we have to replace it to the original variable, that is x. Hence, here taking square root on both sides, root x is equal to tan theta. Then this can be written as tan inverse of root x is equal to theta. Let it be as it is. Okay, in the RHS, 1 by 2 times cos inverse of 1 minus x, I will write it as tan square theta. 1 minus tan square theta divided by 1 plus tan square theta. This is equal to 1 by 2 times cos inverse of 1 minus tan square theta by 1 plus tan square theta. According to this formula, it is cos 2 theta. You see, cos inverse cos get cancelled. 1 by 2 into 2 theta it is. 2 get cancelled. This is nothing but theta. Theta in terms of x, it is tan inverse of root x. Tan inverse of root x. This is nothing but LHS. Hence, we have proved tan inverse of root x is equal to 1 by 2 times cos inverse of 1 minus x by 1 plus x. This is problem number 9 in the miscellaneous exercise. Now, we will go to the next problem, that is problem number 10. Problem number 10 is prove that cot inverse of square root of 1 plus sin x plus square root of 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus sin x, which is equal to x by 2, where x belongs to the open interval 0 to pi by 4. Okay, we are going to prove this one. Here you take the LHS. LHS is equal to cot inverse of square root of 1 plus sin x plus square root of 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus sin x. Okay, to simplify this, I will rationalize the denominator. See, rationalizing factor of this one is square root of 1 plus sin x plus the square root of 1 minus sin x. So, with that I will multiply numerator and denominator. Let me write this first as it is, square root of 1 plus sin x plus square root of 1 minus sin x divided by square root of 1 plus sin x minus square root of 1 minus sin x. Now, multiplying and dividing by rationalizing factor, that is square root of 1 plus sin x plus square root of 1 minus sin x, square root of 1 plus sin x plus square root of 1 minus sin x. Numerator you observe, it is like a plus b into a plus b. A plus b into a plus b is a plus b whole square. Cot inverse of square root of 1 plus sin x plus square root of 1 minus sin x whole square it is, divided by. Now you observe the denominator. Denominator is like a minus b into a plus b. A minus b into a plus b is a square minus b square. Means root of 1 plus sin x whole square minus root of 1 minus sin x whole square it is. I am using 8th standard basic formula, that is a plus b whole square. Now what is a plus b whole square is equal to? A plus b whole square is equal to a square plus b square plus 2ab. Here a is this whole thing, square root of 1 plus sin x. B is this whole thing, square root of 1 minus sin x. Okay. I have cot inverse of a square, square root of 1 plus sin x whole square plus b square, square root of 1 minus sin x whole square plus 2ab. 2 into square root of 1 plus sin x into square root of 1 minus sin x. Whole divided by denominator. Square root get cancels. We have 1 plus sin x minus of 1 minus sin x. You have to be careful here. This minus get multiplies to both the terms. Now in numerator also square root we are going to cancel. Cot inverse of it is 1 plus sin x plus of 1 minus sin x plus 2 times root a into root b can be written as root ab. Means square root of 1 plus sin x into 1 minus sin x divided by, here 1 plus sin x minus get multiplies to both the terms, minus 1 plus sin x. You see, plus 1 minus 1 get cancelled in the denominator. In numerator, plus sin x minus sin x get cancelled. Now we will write the remaining cot inverse of 1 plus 1 2 plus 2 into square root of, you see it is 1 plus sin x into 1 minus sin x. A plus b into a minus b. It is nothing but a square minus b square. Means I have 1 minus sin square x divided by sin x plus sin x, 2 times sin x. Cot inverse of, you take 2 common from the numerator, 2 into 1 plus square root of 1 minus sin square x is nothing but cos square x. Using the formula sin square x plus cos square x is equal to 1 divided by 2 times sin x it is. 2 get cancelled. I have cot inverse of, again you will see square and square root get cancelled. This is 1 plus cos x by sin x now. Cot inverse of, we will go to the half angle formula. 1 plus cos x is nothing but 2 times cos square x by 2 and 1 minus cos x 2 times sin square x by 2. Those formulas you should know. And sin x, using half angle formula, it is 2 times sin x by 2 into cos x by 2. 2 get cancelled. 1 time cos x by 2 get cancels. I have cot inverse of cos x by 2 by sin x by 2. Cot inverse of cos x by 2 by sin x by 2. It is nothing but cot x by 2. Cot inverse get cancelled. X by 2 is the answer. This is the required RHS. This is about problem number 10 in the miscellaneous exercise. Now we will go to the next problem, that is problem number 11. Problem number 11 is prove that tan inverse of square root of 1 plus x minus square root of 1 minus x divided by square root of 1 plus x plus square root of 1 minus x, which is equal to I am writing it here, pi by 4 minus 1 by 2 times cos inverse of x, where x takes the value greater than minus 1 by root 2 but less than 1. This one we are going to prove. Very simple it is again. Let us take the LHS. Before going to the LHS, just by saying this, what we can substitute for x? X is equal to, suppose we substitute for the formulas like cos 2 theta. 1 plus cos 2 theta we will have, and also 1 minus x is there, we will have 1 minus cos 2 theta also. What is this 1 plus cos 2 theta and 1 minus cos 2 theta formula? 1 plus cos 2 theta is 2 times cos square theta, and this is 2 times sin square theta. You see, if I substitute x is equal to cos 2 theta, this simplifies the problem. Square is there, any root and the square will get cancels out. Root 2 will be common. We saw that you can simplify it. Okay. Take the LHS. LHS is equal to tan inverse of square root of 1 plus x minus square root of 1 minus x divided by square root of 1 plus x plus square root of 1 minus x. Here you substitute x is equal to cos 2 theta. This is nothing but cos inverse of x is equal to 2 theta. Take this 2 to the left hand side. I have 1 by 2 into cos inverse of x is equal to theta. That one we will substitute finally. LHS is tan inverse of square root of 1 plus. In place of x, I am substituting cos 2 theta minus square root of 1 minus cos 2 theta divided by square root of 1 plus cos 2 theta plus square root of 1 minus cos 2 theta. Tan inverse of 1 plus cos 2 theta. Just I wrote the formula. It is 2 times cos square theta. Square root of 2 times cos square theta minus square root of 1 minus cos 2 theta formula is 2 times sin square theta divided by square root of 2 times cos square theta again plus square root of 2 times sin square theta. Tan inverse of, this can be written as root 2 into root of cos square theta. For that root cos square theta, square root get cancels. We have root 2 into cos theta. In the same way here, root 2 into sin theta divided by root 2 into cos theta plus root 2 into sin theta. Tan inverse of root 2 we can take common from both numerator and denominators. Root 2 into cos theta minus sin theta divided by root 2 into cos theta plus sin theta it is. Okay, root 2 get cancels. Next, to have this, what to do? Here we will divide by cos theta. Why to divide by cos theta here? We know that tan of pi by 4 minus theta is equal to, what is tan of pi by 4 minus theta is equal to? Tan of pi by 4 minus theta, it is like the tan of a minus b. Tan of a minus b formula, tan a minus tan b divided by 1 plus tan a into tan b. Applying this, I have tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. Tan pi by 4 value is already known to us, that is tan 45 degree is 1. 1 minus tan theta divided by 1 plus tan theta. See, this inside the bracket we will try to convert into 1 minus tan theta by 1 plus tan theta, so that can be written as tan of pi by 4 minus theta. To have the form, let us divide numerator and denominator by cos theta. Dividing numerator and denominator by cos theta. This is just the formula I have written. We will write here. We know that this is the formula. Okay. Tan inverse of dividing by cos theta, it will be cos theta by cos theta minus of sin theta by cos theta, and here also cos theta by cos theta plus of sin theta by cos theta. Cos theta, here also cos theta get cancelled. Tan inverse of 1 minus sin theta by cos theta is tan theta divided by 1 plus of, again it is tan theta. See, we got the form 1 minus tan theta by 1 plus tan theta. That can be written as tan of pi by 4 minus theta. Tan inverse of pi by 4 minus theta. Tan and tan inverse get cancelled. We have pi by 4 minus theta, which is equal to pi by 4 minus of, what is theta? Theta is nothing but 1 by 2 times cos inverse of x. You see, this is the required RHS. So, problem number 11 completed. Going to the problem number 12 here. Problem number 12 in the miscellaneous exercise. Prove that 9 pi by 8 minus 9 by 4 into sin inverse of 1 by 3, which is equal to 9 by 4 into sin inverse of 2 into root 2 by 3. That one we need to prove. Okay, we will take LHS. LHS is equal to 9 pi by 8 minus 9 by 4 into sin inverse of 1 by 3. This one is, what is common here? 9 by 4 is common. Also you see here 9 by 4 is required for us. Take 9 by 4 common. 9 by 4 into, now the remaining pi, and here 2 will be there. Pi by 2 minus of sin inverse of 1 by 3. Sin pi by 2 minus sin inverse of 1 by 3, you can use the direct formula here. What is that? Using sin inverse of x plus cos inverse of x equal to pi by 2 for x belongs to the closed interval minus 1 to plus 1. See, if I take the sin inverse of x to the right hand side, that becomes pi by 2 minus sin inverse of x. Pi by 2 minus sin inverse of x is nothing but cos inverse of x. So in place of x, 1 by 3 is that here. We will write the LHS as LHS is equal to 9 by 4 times cos inverse of 1 by 3. I am using that formula. But RHS is in terms of sin inverse. For that, you convert it by taking cos inverse of 1 by 3 is equal to theta. This is cos theta is equal to 1 by 3. Cos theta is equal to 1 by 3. Put it in a right angle triangle by considering theta here. Cos is the ratio of adjacent side and hypotenuse. This is 1 by 3. What will be the opposite side? Opposite side, it is square root of 3 square minus 1, square root of 8. Square root of 8 is nothing but 2 into root 2. You check it using Pythagoras theorem. Okay. Now sin theta we want here. Sin theta is equal to, from this opposite side by hypotenuse, 2 into root 2 by 3. This is nothing but theta is equal to sin inverse of 2 into root 2 by 3. Yes, theta is equal to cos inverse of 1 by 3 and theta is equal to sin inverse of 2 into root 2 by 3. From these two, I can write LHS as 9 by 4 into sin inverse of 2 into root 2 by 3. This is what? This is our required RHS. With this, problem number 12 completed. Going to the problem number 13. Problem number 13 says, solve the following equations. Solve in the sense of find the value of x which satisfies it. Solve for x. Here solve 2 times tan inverse of cos x which is equal to tan inverse of 2 times cosecant x. We need to solve it. Yes, sir. Left hand side, you see, left hand side is like 2 times tan inverse of x. What is 2 times tan inverse of x is equal to formula? Totally it has 3 formulas. 2 times tan inverse of x is equal to, as right hand side also tan inverse is there. I will use in terms of tan inverse. Using 2 times tan inverse of x is equal to tan inverse of 2x by 1 minus x square. I am using this. In place of x, cos x is there here. That's all. Okay. Left hand side it will be tan inverse of 2 times cos x divided by 1 minus of cos square x, which is equal to tan inverse of 2 into cosecant x is that this can be written as 2 by sin x. Both sides tan inverse is that one you can leave. Now 2 times cos x divided by 1 minus cos square x is nothing but sin square x, which is equal to 2 by sin x. Now you cancel the like terms. 2 get cancels. Sin x 2 times here, sin x single time. This is nothing but cos x by sin x is equal to 1. Cos x by sin x is equal to 1 is cot x is equal to 1. Cot x is equal to 1. Yes, cot x is equal to 1. This 1 can be written as cot of pi by 4. Cot of pi by 4. Cot x is equal to cot pi by 4. This implies x is equal to pi by 4. So x is equal to pi by 4 satisfies the answer. This is about problem number 13. Now we will go to the problem number 14. Problem number 14 says, solve tan inverse of 1 minus x by 1 plus x, which is equal to 1 by 2 times tan inverse of x for x greater than 0. Here, left hand side you see tan inverse of 1 minus x by 1 plus x is that, which is equal to 1 by 2 times tan inverse of x. Which formula to use? We know the formula. Tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus x into y. We will use this formula here. Left hand side you see it is like RHS of this expression. Tan inverse of x minus y by 1 plus x into y, where x is considered as 1 and y is considered as a x. Okay. Using this formula, this left hand side statement can be taken as tan inverse of, I will write here using this, using tan inverse of 1 minus tan inverse of x, which is equal to 1 by 2 times tan inverse of x it is. It simplifies the problem. What is the tan inverse of 1? Tan inverse of 1. Tan 45 degree is 1 here. So we will write this one as a pi by 4. Pi by 4 minus tan inverse of x is equal to 1 by 2 times tan inverse of x. We need to find x here. That's why you take this tan inverse of x to the right hand side. pi by 4 is equal to 1 by 2 times tan inverse of x plus tan inverse of x. Pi by 4 is equal to, what is common here? Tan inverse of x is common. 1 by 2 plus 1 into tan inverse of x. Pi by 4 is equal to 1 by 2 plus 1 is nothing but 3 by 2. 3 by 2 is equal to tan inverse of x. Take this term to the left hand side. It is 2 pi and 4 into 3, which is equal to tan inverse of x. 2 ones are 2 twos are. It becomes pi by 6. Pi by 6 is equal to tan inverse of x. Tan inverse of x that can be written as tan pi by 6 is equal to x. Tan pi by 6 means tan 30 degree. Tan 30 degree value 1 by root 3. So x is equal